Welcome to the next lesson where we are going to look at solving logarithmic equations. So this is one of the applications we're going to look at. A logarithmic equation is an equation that contains the logarithm of a variable. We're going to use the laws of logarithms to help us solve for these logarithmic equations. There are three examples that I'm going to show you. A lot of the time when you're solving for logarithmic equations, you do follow similar principles to solving for them, but they do require different steps depending on what type of question it is. And it is based on intuition. If you practice enough, you'll know exactly what you're going to do for these type of questions. So try to follow the steps and guidelines that I'm going to provide for you in these examples, and then practice them enough so that you know when to use them. For example 1, we have 5 is equal to log base 2x plus log base 2 of 2x. The first thing you want to do when solving for a logarithmic equation is to combine your logarithms using the logarithmic rules. And a reminder that when you combine logs, remember to have the same base so that we can combine those logarithms. Otherwise, you won't be able to combine them at all. So in this case, right away, I can see that I can use our product rule because we have log base 2x plus log base 2 of 2x. So this is our product rule here. And then I want to combine them. We have log base 2 of 2x squared. Now our second step is that we can rewrite this into our exponential form instead. Our base is 2, our exponent is 5, and the answer is 2x squared. Then our last step is to solve. So what I can do is divide both sides by 2. Then we're going to get 2 to the power of 4 is equal to x squared. To the power of 4 is 16. Square root both sides, so x is equal to 4, and that is our answer. Here's our next example. This one's a little bit different, but we're going to start in the same way. We're going to combine our logarithms using our logarithmic rules. In this case, I can see the left-hand side. I can combine it because you have two terms. I'm going to use our power rule because I have a 2 in front of that log x, and then because of a minus between those two terms, I'm going to use the quotient rule. So our numerator is going to be x squared from our power rule, and then our denominator is going to be x plus 2 from our quotient rule. This is equal to log of 2x minus 3. Now because I have a log of something is equal to log of something, I can cancel out my logarithms on both sides. You couldn't have canceled your logarithms yet from the beginning of the question because we have two terms on the left-hand side. We can only cancel them out if we have log of something is equal to log of something. And that's because I can raise the logs as powers using a base of 10, and if I do that, the 10 and the log would cancel out. Here is what it would look like if you're curious about what I'm talking about. So you would raise all this to a power, your logarithms to a power, using a base of 10. And because logarithms are in base of 10, these would cancel out, so you're just left with whatever was inside of that logarithm, which is what we're going to do here. So down we have x squared over x plus 2 is equal to 2x minus 3. And now we're going to solve. So I'm going to multiply both sides by x plus 2. And then simplify the right-hand side by expanding. This is 2x squared. 2x times 2 is 4x. Negative 3 times x is negative 3x. And then minus 3 plus 2 is negative 6. Now I'm going to rearrange so that all my terms are on one side. So I'm going to I'm going to subtract both sides by x squared, which leaves us with x squared. I'm going to combine 4x and minus 3x, which is positive x, and then we're left with negative 6. Here I'm going to factor. We're going to use the factor 3 and 2 to obtain 6. And then in order to get a positive x as our middle term, I need a positive 3 and a minus 2. So once we solve for this, we're going to get x is equal to negative 3, 2. Before I say this is my final answer, I do need to check to make sure that these solutions are valid. Right away, I can tell that x equals negative 3 is not a solution. Why? Because if I were to plug negative 3 as my x into the original part of the question, we're going to get an extraneous solution because we get 2 log of negative 3 from the very first term, and already negative 3 cannot be in the domain of x because we can't have a negative argument in a logarithm. So this can't happen, which is why we can't have x equals negative 3 as a solution. So please remember to check your x values at the very end to make sure if it's a solution or not. Moving on to example 3. Again, the first thing we're going to do is combine our logs. On our left-hand side, we can combine using the product rule. And then I'm going to simplify our middle, or the inside of our logarithm. So we have x plus 3 times x plus 4, which is x squared, plus 7x plus 12. Just like example 1, I'm going to change this to exponential form. So we have a base of 6, our exponent is 1, and then our answer is x squared plus 7x plus 12. Now we're going to solve by rearranging so that all of our terms are on one side of the equation. I'm going to subtract 6 on both sides, so we're going to get plus 6 here, and then we will factor. I'm going to use factors of 6 and 1 to get 6, and then for middle term to get 7x, we're going to need a positive 6 and a positive 1. So x is equal to negative 6 and negative 1. Again, we need to check our solution. So if we plugged in a negative 6, we're going to have a problem because we'd get negative 6 plus 3, which is negative 3, and we cannot have a log base 6 of negative 3. So we know for sure negative 6 is not a solution. However, negative 1 will be fine because if we plugged in negative 1 in for x, we'll still get positive numbers for our logarithm. So our final answer is just going to be x is equal to negative 1. For the next two questions, I want you to try it yourself. I did make a little typo in there, so please change the base of 4 to a base of 3. So you have log base 3 of 9x plus log base 3 of x is equal to 4. So go ahead and try those two questions on your own, and then when you're ready, press play for the full solution. So here's the full solution to this try it yourself. The first thing you should do is combine your logarithms on the left-hand side, then change to exponential form, divide both sides by 3 squared, and then solve for x afterwards. X is equal to 3 for A. Then for B, on the right-hand side, you want to combine your logarithms, simplify the inside of that logarithm, change it to exponential form, factor, and solve. And remember to discard your solution, which is x equals negative 4. Moving on to example 4. This type of question is different now because we are given a question in exponential form instead of logarithmic form. So again, you need to follow the guidelines that I have, and the steps may be different depending on the question. The more you practice, the more intuitive it'll be for you. So here is a solution to example 4a. We're given 9 to the power of x is equal to 50. We were solving for exponential equations before, and how we would do it is we would change both sides of the equation so they have the same base. In this case, it's pretty clear that we can't do that because I can't change 50 to a base of 9, nor can I change it to a base of 3. So in this case, this is when we're going to use logarithms. I'm going to take the log of both sides. So it's going to look like is log of 9 to the power of x is equal to log of 50. Now I'm going to bring down that x in the front of the log. So I'm going to use laws of logarithms. So I'm going to bring the x down because it was an exponent. This is from our power rule. Next thing I'm going to do is isolate x. I'm going to do that by dividing both sides by log 9. Then we're left with x is equal to log 50 over log 9. If this was a calculator question, you can go ahead and plug this into your calculator of log 50 divided by log 9 and then round to the nearest 3 decimal places. Or if it was a non-calculator question, you would just leave it like this. Moving on to example 4b. In this case, we have a 2 in front of the 5 to the power of x minus 2. What I commonly see students do, so don't do this, is multiply this 2 with a base of 5. You can't multiply when you don't have the same base. But what I can do, because there's no exponent over here, with 100, I can actually divide both sides by 2 first. So then we're going to get 5 to the power of x minus 2 is equal to 100 divided by 2 is 50. And if you take a look at this, I can't change 50 to a base of 5, so we are going to have to use logarithms. So I'm going to take the log of both sides. So we have, I'm just going to skip a step here and bring my exponent down. And I just used our power of logarithms rule. So I took the log of both sides, and remember I just took the exponent and put it back down using our power rule from logarithms. I'm going to expand on the left hand side. So this x is going to multiply with log 5 and the negative 2 is going to multiply with log 5. And then now I'm going to isolate x. So I'm going to move the 2 log 5 to the other side and then divide both sides by log 5. And that is your final answer. Again, if you have a calculator, you may go ahead and find our decimal place. Or if it's a non-calculator question, you could just leave your answer as a fraction like that. Moving on to part C. This case we have 2 to the power of x plus 3 is equal to 6 to the power of x minus 1. In this case here, it's pretty clear that you can't obtain the same base, so I can't change 6 to a base of 2, so we are going to use logarithms here. And I'm going to start by taking the log of both sides. And in this case, I'm just not going to skip a step so you can fully see what I'm doing. So it's going to be log 2 of x plus 3 is equal to log 6 of x minus 1. Now I'm going to bring down the exponents using our laws of logarithms. So the x plus 3 is going to come down, multiply with log 2. The x minus 1 is going to come down, multiply with log 6. Next step, I'm going to expand. So it's x log 2 plus 3 log 2 x log 6 minus log 6. Now I'm going to isolate x. So I'm going to move x to one side. So any term that has an x in it, I'm going to move it all to one side and then throw the other things on the other side of our equation. Okay, so I move this x log 6 with the x log 2 and then everything else the other side. Now I'm going to factor out that x. And then divide both sides by log 2 minus log 6. And that is your final answer. Again, you could evaluate this into your calculator to find its exact value with the decimal place rounded, or you can leave it as a fraction like that as your final answer if it is a non-calculator question. Now you can go ahead and try it yourself. There's 2 questions there, and then when you're ready, press play for the full solution. So here's the try it yourself. In part A, I divide by 3 on both sides first, so I can get rid of that 3 next to the 2x plus 1. Then I took the log of both sides, brought down the exponent, and multiplied it with the log 2. I rearranged and solved for x. In part B, I took the log of both sides, brought down my exponents, rearranged my equation so that I have the x terms on one side and log 3 on the other side. Then I factor out the x and then divided both sides by log 3